Hey guys, I am going to take a couple minutes to explain to you a word that you've seen kind of thrown around a little bit, but I've never really explained exactly what it is yet. And that word is a function. And I'm going to start off by relating this math idea to a non-math situation. I haven't been doing it so much this year because I've been trying to be a little bit healthier. But man, I used to drink a lot of Diet Mountain Dew. Okay, and I'm very grateful that the Coke machine downstairs in the teacher's lounge has Diet Mountain Dew in it. So I go down to the Coke machine, and I'm going to use the word input to describe the idea of me hitting the Diet Mountain Dew button. You guys have heard the word input before. Basically means like the information that is going into something. You can put input into a computer. In 6th grade, you guys heard about actually equations having input. Like X was what went into the equation, and then the output is what came out, and you use that as Y. So that's kind of what we're doing here. So I'm hitting the Diet Mountain Dew button again for my input, and then what had better happen is I'd better be getting a Diet Mountain Dew out of the machine. Let's say I go down later on and I say, yep, gonna have another one. I go in, I hit the Diet Mountain Dew button again, and I get another Diet Mountain Dew for my output. Makes sense that should happen. But let's say I go later on in the day for a third time and I hit the Diet Mountain Dew button, and then, really big bummer, a Coke comes out. So I've hit the exact same input every single time, but I didn't get the same output every single time. Okay, that is an example of something that is not a function. In other words, it is not functioning correctly. If I constantly hit the same input, that's a Diet Mountain Dew button, I better be getting the same output. That is, I better be getting a Diet Mountain Dew. What the heck does this have to do with math? Well, let's look at the little notes page that you guys have here for a minute. And so I'm going to give you a definition of function that doesn't necessarily, this isn't the definition you would find if you were to look it up in a textbook, but I have found that this definition makes a lot of sense to kids. Okay, for something to be a function, this is a big if. So if it has the same input, again, we use the letter X to represent input. We've talked about this when we've talked about rate of change and stuff like that. It must have the same output. So I hope you're writing this with me. In other words, if any of the if any of the X's are the same, they better have the same Y's to go with them. So if we've got a set of ordered pairs, for example, I sure hope we remember that X is the first one, Y is the second one in the ordered pair. So what you need to do to determine, let's say you have a set of ordered pairs. So here I've got set number 1, here I've got set number 2. And it says, so we're looking at the steps. First, I need to look at all the X values. And it says, if an X is repeated, I need to check and make sure that it matches up with the same Y value every time. So in other words, I hit the Diet Mountain Dew button, I better be getting the same Diet Mountain Dew out every single time I hit the Diet Mountain Dew button. And it says, if it is matched with a different Y value, just like my example with the Diet Mountain Dew, it is not a function. So let's look at a couple of examples, shall we? Okay, so set number 1, which I already labeled. So it says step 1, which you should have on your paper, is check to see if any X's are repeated. And oh, yep, I've got a 1 and a 1. Here I've got a 3 and a 3. So I do have repeated input. It's okay to have repeated input. The same way that I can hit the Diet Mountain Dew button more than one time, I can have more than one 1. right here for my input. But I better have the same output to go along with it. So that's going to be an issue in that case, because here I have a 1, and then I've got a 2, but then here I have a 1, and I have a 4. So I have the same input, but I have different output. And then in the same case here with the 3, I have a 5 for the output. And then when I have another 3, I have a 6 for the output. So this is not a function. Compare that to example number 2. So here I have zeros that are repeated. I don't have anything else repeated. All you're worried about is when you have repeated values. Okay, so I've got a 0, but it's paired with a 2. And I have another 0, and it is paired with a 2. So yes, this is a function. You can have the same x values repeated as long as they are paired with the same y values. Now this little diagram right over here to the side may look a little bit strange to you, but it's really just another way of representing a set of ordered pairs. So basically, it's called a mapping. We don't see it too often in 8th grade. This is more of an Algebra 1 thing, but it's good to see your exposure now. So this, for example, means that the x is 4 and the y is a 1. And then this ordered pair, you have a 5, and then follow the arrow, and it's paired with a 3. Here we've got a 6, and it's paired, I'm following the arrow, with a 2. So far, I don't have any x's that are repeated. But now I've got a problem. So what this means, the fact that I have a 7 and I have 2 different arrows going from it, it means that I've got an x value that's a 7, but it's paired with 2 different y values. One of them's an 8, and one of them is a 2. So if I were to write that as an ordered pair, it'd be like 7, 8, 7, 2. So mayday, mayday, I've got the same repeated x values, but they're paired with different y values. So this is not a function. Last but not least, let's look at the table. So I've got a 3 in both places in the x column, and unfortunately, one is paired with an 8, and well, not really unfortunately, who cares if it's a function or not, right? So 3 is paired with 8, and then 3 is also paired with 9, so this one is not a function. In the next spot on your notes, you're going to notice that you've got a section that says, what if no x's are repeated? Okay, so then you just automatically assume that it is a function. Kind of like innocent until proven guilty kind of thing. If there's no proof with an x repeated with a different y, then you assume that it's a function. Okay, so for example, this 2 is only paired with a 4. Now this -7 is paired with a 4. This -1 is paired with a 2, and that 0 is paired with a 2. That's okay. Okay, you can have the same y's with different x's. Okay, so because here you have every single x that is different, you just need to stop. This is automatically a function. You don't even need to look any further. Same deal here. I've got a 2, I've got a 3, I've got a 7, I've got a 9. Yep, I'm automatically going to assume it's a function. And then last but not least, sometimes people get confused with this one because all the x's are different, but you'll notice that all of the y's are a 0. So sometimes people think that that means it can't be a function. Well, that's absolutely not true. This is a perfect example of the function y equals 0 times x. No matter what x is equal to, if you multiply it by 0, the y that comes out is always going to be a 0. So it makes sense that this one is still a function. Bottom line, the only thing that matters is looking at the x's. And if none of your x's are repeated, then you're going to automatically assume that it is a function. Now what I'd like you to do is turn your note page over. You should have a blank piece of paper over there. And I am going to give you a couple practice problems. I want you to pause the video. I want you to write yes or no whether or not you think this set of ordered pairs is a function. And then restart the video when you're ready to check yourself and decide whether or not you're correct. I'm going to assume that you've paused the video and that you have tried this on your own. As you can see, I've got a 1, I've got a 3, and I've got a 4 in my x values. So I don't even need to look at the y values. I automatically assume that this is a function. Go ahead and write down on your paper another one. This set. Pause the video, write yes or no, think of a reason in your head. I'm hoping that you have restarted the video. So we've got 2's right here, which is okay as long as they've got the same y value. But nope, I've got a 3, I've got a 7, I've got a 5. This is just like hitting the Diet Mountain Dew button 3 different times and getting 3 different beverages out. Just doesn't make any sense. So this is not a function. One more. Take a moment, decide whether or not it's a function. Hopefully you paused the video if you needed time to think. This one is in fact a function because you look at your x's and every one of them is different. This is actually an example of the function x divided by x. If you take x and you divide it by itself, you're always going to get 1 for your y. See? 5 divided by 5. So this is an example of a function. So bottom line, all the x's are different. Yes, it is a function.